I'm glad to present the research we recently did on AIS. And as I just said now, this is a kind of follow-up to the first part of the research that we present last year in Kuala Lumpur in Hacking the Box. I'm going to briefly recap what we already explained back in October so that you have an understanding of what is AIS and which are the basic attacks that we already disclosed. And then I'm going to present some more threats related to the ship industry. And so my name is Marco and I work for Trend Micro Research. And this is a joint work project with Kyle, a colleague of mine, and Alessandro, independent researcher. So for anything that any question you might have on previous work, I point you to the presentation of our talk at Hacking the Box. So the slide of our first talk are available over the internet. So you can easily download the PDF and check there whatever question you might have, or you can come back to me and just ping me. Okay, so to give a quick introduction, AIS is an acronym for Automatic Identification System. Okay, it's a system for tracking vessels, ships on a global scale, worldwide. Okay, so it's used for ships to communicate with nearby ships via radio frequency, and it's also used for communication from the port to the ships, to control the ship, for example, they enter into the port, or to make sure the ship they don't crash against rocks or against our ships. And it's also used for general to prevent piracy, and it's also used for collision avoidance. So you can, with AIS, it's possible to set a route for a ship to make sure that the ship follows a certain route and does not crash against our ships. It's used in search and rescue operation, in accident investigation, and more. So AIS has been introduced as a mandatory installation in 2002, and later on in 2006 has been extended to all international ships with a gross tonnage of 300 and all passenger ships regarding on their side. That means that nowadays there are an estimated number of roughly 400,000 in installation worldwide, and we expect it to be over 1 million in the near future. So that's the magnitude of a problem. So to give an idea, AIS, the architecture of AIS is that what you see here in the picture. So basically, as you can see, there are ships that talk each other via radio frequency, and also talk with, that one in the middle is a buoy, what is called head-to navigation. So buoys are used to instruct the ship on, certain condition of the sea, or if there are problems at the moment, and so on. So it really adds to navigation. So all the ships, they talk each other via VHF. And on top of that, they also talk with AIS gateway. So this gateway, they collect AIS information and upload the information, upstream information over the internet. So the AIS, the AIS transponder works by having a GPS that locate the ship, okay, and then the information that is broadcast to the other ship nearby and also to the internet is the position of the ship together with some static data on the ship, like its name, the cargo, the site, the nationality, which kind of goods is carrying. For example, it's carrying nuclear goods. If it's a military ship, it's a passenger ship, whatever. So in this talk, we are going to present two major threats affecting this technology. So one threat is related to the implementation side of the problem, and it corresponds to the guy that is located on the corner up left. So we'll see how we can basically attack via software all the AIS provider that provide such data over the internet. And then we also see how an attacker can possibly attack via radio frequency AIS, the protocol itself. So as I said, AIS messages are exchanged in two different forms. That's very important. So the first form is via radio frequency. So there are two channels, roughly around 162 megahertz, that are used for the communication between ships and port authorities. And then another form of exchange message, AIS message, is via online AIS provider. So one example of provider is marine traffic. So this provider, for example, it collects information on ships that are located at the moment roughly in a port of Singapore. Do you see you have different colors because for different ships, you have the position where the ships are located, you have information on how many vessels have arrived that day, how many vessels have left the port, and so on and so forth. So online AIS provider, they simply collect information, AIS information, they process them, and then they provide this information either for free or by paying the information. They provide them to different parties. For example, this site is free, so you can easily access this site and retrieve information. Our provider, they provide information to port authorities or to special customers for different needs. So how the data are collected by this online AIS provider? There are different ways of upstream the data to the provider. So one way is to use a mobile app. So if you have your ship and you want to upstream data, upstream the position of your ship, so communicate the position of your ship, you can use a mobile app if you have a 3G connectivity. You can use some software. You can use emails. So you can regularly send, for example, email to the online provider and we'll process them. You can use, there are different API to do it. But the most used way for provider to collect AIS information is by using gateway. So there are these gateway that are like towers, like in the example I showed you before. So like this one. There are these towers that are deployed regionally on the coast. And they basically listen for radio frequency data and they upstream them to the cloud. Okay, so that's a quick recap on AIS. So if you want more detail, I point you to my presentation at Hack in the Box, or you can even, if you go to Wikipedia, there is a full page describing how it works. So now we want to focus more on the threats because we are in a security conference. So we want to see where are the problems here. So there are two macro categories of problem. So the first one is related to implementation specific. So are problem that only concern the online providers. So that's nothing to do with radio frequency or with the protocol itself, but it's only an implementation problem of a provider. And it is a threat, is a group of threat, but in my case, they are not so severe as the second type of threats. So the second category of threats are protocol specific, which means that there is a problem in the specification of the AIS protocol. And since there is a problem there, all the AIS transponder deployed globally, that are more than 400,000, they have problems. And this type of problems are not easy to be fixed, because to fix a problem in transponder would mean to update the transponder, update the firmware of the transponder. And it's not easy when you have a transponder installed on a ship without interconnectivity, and it's not like updating the firmware of my iPhone, right? That I can download it from the internet, done. Okay. So now let's a bit talk, we give a parenthesis about in which format AIS messages are exchanged. So we use a format called AIVDM, and there are message type for different information that are exchanged among ships. For example, there are message used to report the position of a ship, latitude, longitude, the course, the speed. There are messages that are used to exchange static information on static, what are called static information, like the name of the ship, the country, which kind, as I told you before, which kind of goods they are is carrying, and so on. Then there are other messages that are reserved for to port authorities. So AIS transponder normally are not allowed to transmit such message. They are only able to receive them, and these are used for management purpose. And then there are other that are safety-related message. So what we did first was to write a small tool that allow us to generate the payload for such messages. Okay, so with this tool that it's basically an encoder, so we can generate any kind of AIS messages, and we'll use this tool to perform the attacks that I'll show you later. So both the implementation side attack and both the protocol specific attacks. So in this example, for example, you can see that we can generate a payload both in binary form and in ASCII form for an Italian ship that is involved in military operation. And you can see that it's Italian because every ship has an what is called MMSI, is like the equivalent of a plate that you have on your car. Okay, so each of you on your car has a plate with an ID. Okay, ship have the same, and the three first digit of this ID it corresponds to the country. Then the fact that it's military is because in this message type, that is message type 24, the vessel type 35, it means military. So of course, I'm not going to detail here, but there is a whole encoding of to specify the ship type and so on and so forth. So the first attack we will see, I'm going a bit quick on the first attack because I've already introduced them in October, but to give you an idea of a starting point. So the first attack is pure software. And this attack consists in the ability for a bad guy to spoof ships or add to navigation to the online provider. So the attack itself is pretty easy. So you have your computer, you can craft an AVDM packet by using the tool I showed you before, the AVDM encoder tool. For example, in this case, we are crafting a fake ship that is moving at 5.2 nodes, at latitude minus 96 and longitude minus 96 and latitude 32. And we are using netcat, we are upstreaming the data to the provider. So with this, we can, for example, what we can do, we can, for example, fake a US ship, such as, for example, a military ship that is moving over the Pacific Ocean from LA to North Korea. We can also program a malicious route. So we can use Google KML file as input, and we can say, okay, I want to fake a ship that is moving across the Mediterranean Sea, spelling the pawn word in 12-hour time. So the ship will basically move around and is spelling the word. This is like a game, but this online provider that is marine traffic, he shares data with all the other providers. So if you can inject fake information there, you're basically injecting this information all over the other provider because the data is exchanged. And it's pretty severe because such data are used by port authorities to control ships. They are used by many parties. For example, one of the main use is to detect ships that spill oil illegally in open sea, or ships that use some cheap fuel to operate, but that that might pollute. Actually, there are studies where they show that a lot of ship owners they use fuel that is cheaper but pollute. So what they do, this company, they correlate AIS information with satellite photo, and they can see if there is a ship that is. So they can understand which ship is polluting or which ship is spilling oil or which ship made bad things by correlating information. So if you can change or fake AIS information that are collected by provider, you can blame on someone else. So in the second attack, we are not only injecting false information in the network, but we are actually modifying the existing information. So the attack can be operated in different ways. It can be done completely fully remote by sending to the provider update for an existing ships, and basically, if we do it at faster rate compared to our target, we are able to override the information of the ships. So we can pick up an existing ship and change their position, change its position, or change the type of the ship, or change the name of the ship, and so on. We can also do it by, as it is here in the example, by setting up a rogue gateway. So for example, here in the hotel, we are near to the port. So what we can do, we can have this, we can buy one of these dongles that cost $20, it's kind of USB key. And these dongles are normally used to receive the TV or radio stream. We can plug in the computer, have an AIS receiver that demodulate the traffic, and then we can use our computer to receive AIS information broadcast by the ship here in the Singapore harbor. Then what we can do, we can hijack the traffic, and then we can upstream modify the traffic to the provider. Okay, so it's like a rogue AP. Okay, but this is a rogue AIS gateway. So, as an example, we have Elena Godon, which is a real ship, a real tug ship that is moving across the Mississippi River. And in the video, you will see how we are able to target this ship, and that is operating along the river and moving virtually the ship in the middle of the US, in Dallas, on lake on the back of Dallas. As you can see, the provider does not make any check whatever the information that the ship is providing is real or fake, because we cannot have a huge ship like a tugboat in the middle of a small lake in a golf club in Dallas, right? Okay, so these are threats that are interesting. Of course, they're problematic because basically the information that are provided by AIS provider, they can be easily polluted by cyber criminals. So that means that there is no really way to distinguish between information that are true and information that might be false or wrong. So that's one problem. But what I'm going to show you next is, to me, the cool part of the research. The fact that we target the protocol itself. So we impersonate the guy that is here on the right side of the screen, the attacker. And so we are going to basically generate such fake message, and instead of deliver them to the provider via over the internet, we'll do it via radio frequency. So the real problem here is that AIS has been designed in what I call a hardware epoch. It's maybe only 10 years ago, right? But 10 years ago, these type of hacks, they were more difficult to perform and cost expensive, because to be able to generate a radio frequency signal would have required for attacker to do it in hardware, most likely. There was no easy way of doing it except buying very sophisticated and expensive uh, instrumentation. Okay, so who designed the protocol? Designed the protocol without any form of authentication. So there is no way to authenticate the sender of a message, and without any form of uh, integrity check. That means that there is no CRC, there is no check that the message can be is modified during transmission or not. So what's happened now? Now we are in 2014. Okay, still is cool to talk about buffer overflow and format string, but it's also cool to look at these kind of threats, because in 2014 we have, how can we generate a signal, a radio frequency signal in an easy way? So the answer is to use what other researchers are using since a couple of years. It's a technology called software-defined radio. So it's a technology that has many applications. One is, for example, to receive radio and television communication. As I told you before, there are these USB dongle that for $20 you can buy and can use them. And another application is by radio amateurs. So they used, instead of using a radio to communicate with their friends, a physical radio, they have a software-defined transmitter for doing it. And the idea of a software-defined radio is that they have the cost of creating a radio is reduced because it's done via software, and this also means that the complexity is highly reduced compared to the physical radio, and you have greater flexibility because you can, since you do it via software, you can try different type of radio. You don't have the hardware, because if you do it in hardware and you do a mistake, you have to throw away everything and do it again. So it's very cost expensive and you don't have flexibility. Via software is easy. You can create a radio easily. So this technology nowadays is accessible by many, which means pirates included. So that's our testing lab. So in our testing lab, we have this computer, which is running Debian, with GNU Radio. GNU Radio is probably the masterpiece of a software-defined radio. So it's a framework for developing software-defined radio application. And then we have a software-defined radio peripheral, which is this box, this white box on the right. This software-defined radio peripheral is produced by a company called Ethos Research, and it costs roughly $600. So I don't have with me today because it's a pain in the ass to bring the box with all the cable. We did it in Kuala Lumpur because we were in two on the stage, but today I'm alone, so I didn't want to bring all the equipment. And so we have that box. Basically, you connect the box to the computer USB, use the computer to generate the signal via software, and then you use the peripheral to propagate the signal over there. It's like an access point, more or less, okay, to give you an idea. On top of that, we have an amplifier, what we use to amplify the output of a signal, because so a software-defined radio peripheral is normally used in a lab, but if you want to target a receiver that is 5 kilometers far away from you, you need an amplifier to do it. So we bought a radio and we modified the radio, such as we use the radio as amplifier. And then we have that guy in the middle that has an AIS transponder. That's one of the most used AIS transponder in Europe. It's produced by a German company, and we use it to test that the packet we were generating via radio were correctly received by the transponder. So we use it as a victim for debugging, basically, okay? Cool, so, okay, I'm not going into detail here because I don't know what time is it, but let me see. So we have already burned half an hour. So that's the schema of a transmitter. So the first things we did was to develop an AIS transmitter via software. So we are the first one to develop such stuff. There were some receiver available over the internet. We actually stand up on 3 different receiver, but there was no transmitter. So we developed our AS transmitter. We use GNU Radio for doing it, and GNU Radio provide already some blocks for a modulation and of a signal for example, low filtering, high band filtering, and other standard filtering that you apply on signal. But it was missing the component, that you have on the left, the AIS, what we call AIS frame builder. So we developed such component, and in my presentation at Hacking the Box, I describe how it works in detail. So just to be fast, so what we did, we implemented the AIS stack, which means that component taking input the payload we want to transmit, which is the AVDM message, so the payload, and basically do all the AIS stack processing down to layer 1. It output like a sequence of bits, and then finish. Then what happened, he pass these bits to the modulator, that basically do the GMSK modulation over the 2 different channels. He multiply for a signal source at plus 25 kilohertz and minus 25 kilohertz, and then he send the signal to the USRP device, the URP sync, so the peripheral. So that's our radio. So this is like having an AIS transponder that costs thousands of bucks done via software. Okay, so the first attack I'm going to show you is the radio frequency spoofing equivalent to that one I showed you before in marine traffic. So the setup is like following. So we have a computer running our AIS transmitter and connected to the peripheral that send the signal over the radio. And then we have a target. So the target can be either the installation on port, like this one you see here, or an AIS transponder, like the transponder we bought for the experiment. So as you can see here, we can generate any kind of AIS message over there. For example, this one is for a vessel called Trend Micro at certain latitude and longitude. So as you can see, the transponder here is catching up all the ships nearby. So if I would have come with an AIS transponder, I would have run it here in this moment, you could catch up all the ships that are in the harbor. Okay, and this shows that in addition to a real ship, you also catch up the signal that we fake using our computer. And one application of this is that an attacker can, for example, create a fake buoys and that instruct the existing ships into moving in the wrong direction. So a buoy can be used to say, okay, look, now is low tide on this section of the sea on my right, so you have to go left. So what I can do as an attacker, I can create a fake buoy and instruct the ship into going left instead of right, so I can possibly induct existing ship into crashing against rocks, for example. Or we'll see in the next slide other real example of attacks. We could also generate, when generate actually such fake signal, if we are in the proximity means 30 to 50 miles. So it's not really proximity because it's a lot, I mean, it's pretty huge. And if in the proximity there is a gateway installation of one of these online provider, of course, the signal will be catch up by the gateway and will be upstream over the internet. So with this simple attack, we can target both ships and port authorities and in general AIS stations that are nearby and both online provider. Because if there is one of these gateway, as you can see here in the example, if we fake a ship that is moving on the Mediterranean Sea out of Genoa port, the gateway that is installed in the port will read such message and upstream it over the internet. So if we, in real time, if we look over the internet on the provider, we will see actually our fake ship moving. Okay, so now we start with the real attacks. Do you have some question? Just something that is not clear? Yes? Okay, so you're asking me when we hijack an existing ship, how we block the existing information. So if you do it via software, you basically upstream your fake information over and over rapidly, and so you basically override it. If you do it via radio frequency, you have an amplifier. So normally AIS work at 12.5 watt. Our amplifier work up to I think 30 watt. So if we use higher power when we craft the signal via radio frequency, boom, we basically override existing. Okay. So in this example, it's the first attack is called man-in-the-water spoofing. So in the marine industry, there are some devices that are used to locate a survivor in the sea. Okay, it's a bit like the equivalent of a system used for avalanche to locate a survivor under an avalanche. So these are what is called, they basically emit a distress beacon. Okay, and if there is a ship nearby that receives this distress beacon, the ship should automatically generate an alert. Okay, by specification, and the ship is required to go and rescue the survivor. Okay, and in this attack, we are able to spoof such SOS message to, for example, if you're a pirate, we might generate this fake message to lure a victim vessel into navigating to a sea space that we control. Because if you spoof a message, for example here, for a man in the water that is just here and there is a ship nearby, we can lure the ship into coming in to us and rescue our fake survivor. So in the example we see here, we have top right corner, it's the attacker console. Here on the right, on the top. That's the attacker console, okay? So it's basically the attacker with his computer that is generating the malicious code. Here we have the victim, okay? So this one is a transponder that we have in our room that we use as victim. And that's the alarm, both visual alarm and acoustic alarm connected to the transponder. And this one is the console of a transponder. So the transponder is connected via USB to a laptop, okay, as is in a normal ship installation. And this is what the captain sees basically. The transponder, physical transponder, the console. So in the example you see here, we can see how the attacker generate using our software-defined radio an SOS alert, and how the alert trigger the condition on the transponder. And you can see how the transponder parse the information as alert. Okay, so in the second attack, it's what I called denial service plus plus, because it's denial service against multiple targets. So here, the idea is that the attacker is going to impersonate port authority and to use one of his control message. And one of his control message allow to instruct the transponder to switch to non-default frequency. As I told you before, AIS work on 162 megahertz. So the port authority can instruct the transponder on the port to switch to operate on a different frequency. At this point, if you do like that, we can basically isolate. So we can isolate the ship and we can force the ship to use a wrong frequency. And what's more interesting, we can program what's called desired target region. So we can say to a ship, okay, you're going to switch frequency, not now, but when you enter in a certain region. For example, I can say, okay, when you're going to enter a region like the the Aden Sea in Somalia, which is known to be full of pirate, you're going to operate out of the 162 megahertz. So at this point, when the ship arrive on that region, on the sea space, is AIS radar, we basically stop operating. So the radar, the ship basically will disappear from the monitor of of yeah, of our ship or the port authority that is controlling the ship. So here is the same example as before. So we'll first show that the transponder works correctly because we send him an SOS alert and the transponder react saying, okay, there is someone in the sea. We then pretend to be a bad guy and we instruct the receiver to listen on another channel. So I don't know if you can see here, but I'm saying, okay, you're going to operate on a different channel, not the official one. And what will happen is that the receiver will confirm that the message is received, but later on, he won't react to an SOS alert again. So we show how we can basically turn off a transponder, so make the ship invisible from radars. Okay, it's like turn off the ACAR system of a Malaysian flight that crashed last week, right? So pretty much. Okay, the third attack is called CPR alerting. So there is a kind of autopilot technology that is implemented on most of the vessels worldwide, and it's called CPA, closest point of approach. So basically, all ships having an AIS transponder, they calculate their position automatically with nearby ships. And if there is one of the nearby ships that is too near, that is kind of coming and possibly colliding with my ship, the transponder may react in different way. Okay, one of these ways, for example, to generate an alert, or even to trigger the ship into moving out of course to avoid the collision. So of course, what we can do as bad guy, we can generate a fake ship. That's our victim, okay? So we can generate via radio frequency a fake ship that is colliding with the victim, such as the victim can possibly go out of track and collide against a rock. So we construct a position report for a vessel moving at 102 knots, a certain longitude and latitude, with a certain MMSI, call sign, and vessel. And our vessel appear close to the target victim, okay? What we'll do next, we alter the course of this fake vessel, such as we will point him to our target. So what will happen, our target will trigger an alert estimating a collision in 2 seconds and 3 meters away. So I remember what you see here on the left is a console that the captain has on his ship, and that's the transponder with the trigger the alert. And this is not a joke, so I could easily do from my room here in Marina Bay Sands down to the harbor, because radio frequency in open sea they can run up to 30, 50 miles, and the harbor is just here at maybe 2 miles or 5 miles, so it's pretty severe. Of course, I can even broadcast other type of malicious information, such as the weather forecast. There is a special message type, that is message type number 8, that is called binary, that is used to broadcast generic information. And one use is for weather forecasting. So it can be set next to the seaside, and if there is a storm that is expected to come in, I can say, okay, it's going to be sunny tomorrow. Go and surf, enjoy the sea, guys. Okay, so we still have 20 minutes, and so what I show you now are it's already some cool, interesting attacks. What's going on is even more severe. So this attack is new. It's never been released before. It's called, I call it slot starvation. And this attack, it consists of impersonating a port authority to disable the AIS functionality of all the AIS stations nearby, including ships added to navigation, aircraft involved in search and rescue operation. I didn't tell you this. By specification, all the aircraft that are involved in search and rescue operation, seaside, like those ones that are currently using to locate the Malaysian flight, they are requested to have an AIS transponder installed, okay, to broadcast the position of a plane and also to locate possible survivor in the sea and so on. So of course, this kind of aircraft, they are also affected by the same problem. So this attack, as I said, it's called slot starvation. So what we do, we first impersonate a base station. So the base station is usually near or either on the harbor or along coastline. So there are these base stations that were used to organize the AIS communication. I don't know how many of you are expert, but AIS is a protocol that uses an access scheme that's called a TDMA. So if there are 10 parties involved, 10 stations, they use a round-robin system. So the first station transmit first on the first slot, that is 26 milliseconds. So first slot, second slot, third slot, 10th slot, and then they cycle again. Okay. They use this kind of access schema because they all use the same frequency, so they cannot transmit all together. So they use this round-robin system, okay? It's like a process, it's like, in a computer you have a task list, process list, and if you want to run multiple process, I mean, nowadays over computer, since DOS are multi-processing systems, so you can run multiple processes at the same time, they use exactly the same approach. So there is this base station that organizes the time division of a different station. So what we can do, we can fake such base station and fake a control message that in which we say, okay, Dino, I'm going as base station to book the next 4 TDMA slots, including the slot in which I'm transmitting. So I'm going to book the next 100 milliseconds. So if I do it again and again every 100 milliseconds, what will happen is that me as a fake base station, I will be booking all the TDMA slots. So at that time, since the base station has a higher priority compared to normal AIS stations, the station won't transmit any longer. So basically, I'm going to what I call it slot starvation, because I'm going to starve, so to book all the slots, so to prevent all the stations to transmit. That's the real example. So if we do it on our transponder, that's the console of our transponder, okay? So what will happen is that the transponder will pop up a warning of AIS transmission timeout, and on the right side you can see that the last transmission, you can see here, the last transmission for a position report is 7 minutes 54 seconds ago, and the last transmission for a static data, like the dimension of a ship, the name of a ship, and so on, is 6 minutes and 52 seconds. So this again, if I send this simple message via radio frequency from the hotel here down to the harbor, all the ship there, they will stop broadcasting their position. So I will basically shut down all the AIS system here, okay? So this attack is called timing attack. This is also pretty similar to the previous one. This uses another control message that we designed the the protocol thing that was useful to have. So it's a control message that can be used to instruct a transponder to delay its transmission in time. So I think that when they introduced such product, such message, it was because maybe, I don't know, I'm thinking, maybe you have too many ships in the port, so you don't want them to transmit every n seconds. You want to delay their transmission because there are too many, otherwise there is too much traffic. I don't know. So the default broadcast time is 6 minutes for a static report and 0.5 up to 3 minutes to dynamic report, depending from speed. By using the attack code you can see here, you can basically, if you iterate over 15 minutes, you just say, okay, you know, you're going to delay, I want you to delay the transmission of 15 minutes, and then you do it again and again. So at that time, the transponder won't transmit any longer. So it's actually, the effect is the same as that one you saw before. Of course, you can even do the opposite. So you can even say to the transponder to increase their frequency. So instead of sending a static report every 6 minutes, I can say, okay, send the static report every 1 minute, 30 seconds, 1 second. So what's happening if I have, like here in the harbor, there are maybe 100 transponders, 100 ships. I'm going, okay, all of you have to send your report every 1 second. Basically, I'm going to flood the port authorities. You know, it will be boom. Okay, so that's another attack. This is very different from the previous one. This one is to me, this one will lead to severe problem in the future. So the idea is that AIS messages are exchanged via radio frequency, okay, as I said you before, between ship to ship, between ship to buoys, between buoys to aircraft, between ship to port authorities, and whatever. And they are exchanged, and then in the back end, they are often processed. So usually, port authorities, they have a back-end system in which they collect this message, they parse the message, and then they either store the content of the message in a database, or they use to do different other things. Okay, so what about if you use AIS as attack vector to deliver a malicious payload? Such as, we might be able to trigger a buffer overflow or a SQL injection in the database, because it's exactly the same. There is for example, weather forecast, they use a message type that is generic. So you can basically type in this message, you can insert any kind of data you want. And this message will be delivered to the transponder. The transponder will extract the message, parse the message to the backend system. The backend system will do something. So one example is there are two use weather forecast message. So these messages are processed by backend software like this one you see here, that is a software to plot the current condition of a sea on a screen. So this is used by ship captains to know if there is a high tide, low tide, a storm coming in, or whatever weather problem. And of course, there is no satellization of the data here. So we can induct SQL error in the backend. This is just an example, but here there is no limit to your imagination. And such systems are very old. They don't have any control because when we designed the system, no one even thought that some malicious code can come in via AIS. Okay? So all the problem affecting applications such as buffer overflow, format string, SQL injection, and so on and so forth, they're applicable here to the backend system installed either on ships or in vessel traffic services, okay, in control room. So finally, this last example is related to a problem of our own device. So I'm not sure if all the transponders have such problem, but our transponder, if you generate too much traffic, it basically do a kernel panic. So it will show an error saying there is too much noise on the channel. I don't know when I have to transmit. Okay, because the transmission works as following. So basically the transponder listens to the channel and try to understand when the channel is free and when the channel is booked, because use this TDMA slots division. If there is too much noise on the channel, so if you continue sending messages, even random messages, trash, you want to understand when it's full or when it's booked, so it will pop up an error and will stop working. On top of that, I think the CPU, if you do something like that, you will going to consume either the memory or the CPU or the transponder, because I can see here that it cannot even get a GPS signal. It will tell me GPS no valid fix. So probably the functionality of it, one of the functionality transponder is to get the position from GPS and broadcast it. So if you cannot get the position of GPS, means that there is basically we are overloading the resource of the transponder. So it's very easy for an attacker even to generate kind of random garbage in VR and turn the AIS transponder unusable. We have also a real-world experiment that we conduct to show that the problem we identified is not only related to our transponder and are not only problems that we evaluate in our lab, but we made a real experiment outdoor where we evaluate the coverage, so that we show that it was actually is able from an attacker is actually able to generate, to convey such malicious attack. And we have some video about that. I'm not going to show now because we don't have time, but I'm happy to share with you. So if you come to visit me in the next today or tomorrow, I can show you the video of these real-world experiments. Of course, said that, since these problems are pretty severe, I have to do a responsible disclosure. So I have to say that we conduct this experiment without interfering with the existing system. In particular, messages that have safety implication. So those one, for example, of spoofing collision alert to bring a ship out of track, or message related to SOS, so to like distress beacon. They are tested all in a lab environment. So we connect. For some of them, we connect like the transponder to the radio equipment via wired, and then we reach out upfront the provider that were affected by problems. So marine traffic, AIS app, vessel finder, and ship finder, that are the four major online AIS provider, telling, hey guys, you should validate the data that you collect because they can be everything and nothing. And we also contact the authorities. We contact the IMO, that is International Marine Organization, which is on the top of all the other authorities. We contact ITUR, which is the radio telecommunication sector of the International Telecommunication Unit, and are the guy that wrote the specification. And we contact the US Coast Guard and different other organizations up front, and we share with them our result. And we are actively collaborating with them to have the problem addressed somehow. So some of the countermeasures we propose, and we also propose to this organization body, is to implement authentication to be able to ensure the transmitter is the owner of a ship. Okay, authentication can be done in different ways. We can discuss later. And this prevents spoofing attacks. We also propose to have time check to avoid the replay attack, so the possibility to take an existing packet and replay the packet in the future. We also propose integrity monitoring to avoid tampering with existing AIS message, such as hijacking, as the guy, our colleague, questioned before. And finally, validity check on data context. So if I have, for example, an AIS gateway installation here in Singapore, and I'm generating a packet for a ship that is in Boston, it doesn't make sense that the message of a ship in Boston will reach an AIS gateway here, because there is no way that the radio frequency signal flight travel from Boston to Singapore, right? So they should do some data contextualization on the message. So to conclude, what I want you to take home is that AIS is widely used because since more than 10 years is a mandatory installation for all the vessels traveling worldwide. So there are millions of installations worldwide. And it's also a major technology in marine safety. So it's extensively used because it's been introduced as an enhancement to existing radars. So it should be like the next technology is currently used, and we are pushing for that in the future. And that's why we did this evaluation. And we found out that it's broken not only at the implementation level in providers that collect and provide information online or to special parties, but also at protocol level that is very severe, that is very difficult to fix. So we hope that our work will help in enhancing the current situation. And thanks for your attention, and I hope we'll have a good insight and a good lunch break. So if you have questions, go ahead right now or catch you up later, guys. Thank you. Okay. How can we? But from the software point of view, the fix is kind of not trivial, but you can do it, right? Because it's a problem of providers. So we can implement authentication, we can implement all that things. From the protocol standpoint, you'd mean to update the protocol. But what's more critical, I told you, is to update probably the firmware of a transponder. And it's something that will take time. But at least it's better to know that there is a problem instead of hiding. Because when I was in London last week for a track called V-Tracks, there was mainly like a politician and this guy from the body organization. There was some guy from the port of Singapore, from a major port worldwide. And it seems like they were aware somehow that you could spoof such message, but they hide it. They knew it in their small group, but they hide it. So they thanked to me. They said, we are happy that you share concern with not only our community, but worldwide, so that we can think about that and discuss. They told me, yeah, we are going to discuss it in Brussels, maybe in Europe. Let's see. Sorry? Of AIS? Has been reported some guys that ever program wrongly their transponder because they want to hide certain information on their ship, or they disable the transponder on purpose because they don't want their ship to be visible outside. And even from the online spoofing, if you go, there are known attacks of people that try to spoof information to online providers. But the other attack I show you now, to that extent, not yet. Hopefully, not yet. Yes? Okay. But in the aviation industry, there is a protocol ACARS. Essentially, that protocol, that system that has been disabled on this flight in Malaysia, and it's basically the equivalent for AIS because it's used for monitoring flights. AIS is using for monitoring ships, so it's the same. But in addition, AIS is also a system to control ship because you can use this control message to send some specific control message. For example, switch out of frequency, delay the operation time. So AIS is much more, and it's probably more severe. Yes. Some more question here? Okay. Thanks a lot.